right. So we're going to continue here talking about slope, and then we're going to go into starting linear equations. So just to review, for those of you guys that are on the call this morning, we did just review some slope with our Delta Math homework. For those of you guys that are at home watching this well, you're all at home, but for those of you guys who are watching this on the YouTube channel because you didn't make it to class this morning, make sure that you guys are catching up on Delta Math and make sure we see you on Thursday. If you didn't come to class today, probably a good idea to come to office hours tomorrow. I'll be on from 1:30 to 3. 1:30 p.m. is this class's time. So you need help, or if you missed class today, probably a good idea to check in. It is Tuesday, the 19th of January. So we did this problem. We left off with this problem here before the long weekend on Thursday. So it says the graph represents the depth of a diving submarine over time. At what speed is the submarine descending? And it unshared my screen, didn't it? Google Meet has been doing kind of fishy stuff with me. Oh. We'll just share entire screen. That'll work better. The share a tab function has been glitching on Google Meet lately. All right, so we need rise over run, right? That's what we need. We always need rise over run if we are finding a slope of a line, right? And this is perfect because I already have this up here from I was helping somebody on Friday during office hours. So you know that if you see a line that's going up from left to right, it is a positive slope. You know that if you see a line going down from left to right, it is a negative slope. Once you get better at these, you'll kind of memorize these to positive slope, negative slope. Positive slopes always look like this. They always go up from left to right. Negative slopes always go down from left to right. And you can remember that by just thinking about the way you read. We read in the English language, we read from left to right. Most languages do that. There are a few that don't, but most do, right? So left to right. If it goes up, it's positive slope. If it goes down, it's negative slope. So that is a hint on this problem we're about to do. So we're looking at rise over run from these 2 points that cross at intersections on the grid, which is good. That makes it easy. So we started here at this point right here. That's 200 and that's 0. So that tells me this line right here is negative 100, right? So from this point to this point, we went down 100. Minus 100 was our rise. So I'm going to come over here to the Jamboard and I'm going to write rise over run is our slope, which equals our rise was negative 100. So that's our rise. That's the top number of our fraction in our slope. Now the run is, we went down 100 and then we went, this is just counting by ones. This is minutes. So 1, 2, 3, 4. We went from 4 to 8, right? Which is 4 plus 4 is 8. 4 plus 1, 2, 3, 4 is 8. So our run was 4. And again, this is the same as unit rate, right? It went down 100 feet in 4 minutes. So the slope is literally telling us the unit rate of the submarine. How fast is it going down? We cannot leave it like this because this can be simplified, right? That can be simplified. If you punch this in as your answer into the computer on Delta Math, it will say, you're technically correct, but you need to reduce the fraction, right? Because 100 can be divided by 4 and it will come out to an even number, right? I can do that. You might know that because if you have $1 and you divide it into 4 quarters, what's the answer? I won't even use a calculator here. You guys can do this in your head. If you have $1, you have 100 cents and you divide it into 4 quarters, 100 divided by 4 is what?
$25.
Correct. Yes, thank you. So 100 divided by 4 is 25, and we have a negative sign here, right? So the negative sign stays. It's technically negative 100 divided by 24, so it's going to be negative 25 feet per minute. So that is not only our slope of our line, but that is also representative of the unit rate of the submarine. You see how that, I know we talked about this last week, but I'm just kind of reviewing to make sure we remember. The slope of the line also represents the unit rate, right? So we've graphed the position of the submarine over time, and that also tells us how fast the submarine is diving or descending, right? And obviously it's diving, it's going down, so it makes sense that our answer would be negative, right? If if we were going up in an airplane, it's if this was an airplane that just took off from the runway, our answer would be positive because our plane is going up, right? And then maybe if it was the airplane, about to land, maybe it was 30,000 feet above Earth and now it's going down to 0, our unit rate would be negative because it's going from 30,000 down to 0, back to the ground, right? So just think about that when you're thinking about these graphs. A lot of times you can figure out whether it needs to be positive or negative slope based on the question if they give you a word problem. Submarines go down, so it's negative, right? Or like it says, your car speeds up. You're at a stoplight, you're stopped at the red light, you're going 0, now you speed up to 60 miles an hour. That's positive, right? Or it could say you're driving along at 45 miles an hour and the light turns yellow, so you start to stop and you go back down to 0. That would be negative, right? You're slowing down. But good little review to start us off here. Negative 25 feet per second, right, is the unit rate. It goes down 100 feet in 4 seconds. So that means it's 25 feet in 1 second. And they'll show that here, right? This is what they did. They used y2 minus y1. I used the graphical method. The rise was negative 100 and the run was 400. Or 4, I'm sorry. Negative 100 over 4. And that's what you get right here, right? Negative 100 over 4, which is what they got, equals negative 25 feet per second, or feet per minute. Here it is. So we got the same answer they got, which is good. Did we do this one? Yeah, we did this one too, right? We did the piano lessons. So we're looking at the dollars per hour of piano lessons. We have a point that's $230 and a point that's $690. So we went from 30 to 90. I'm not going to do this one because we've already done it. We went from 30 to 90, so that's $60, right? 60 spaces up. 10, 20, 30, 40, 50, 60. So our rise is 60. Right here, our rise is 60, and our run in hours is 1, 2, 3, 4. Because you can see down here that the hours is counting in ones. So we went up 60 and over 4. So rise over run is 60 divided by 4. You can't leave it like that because 60 divided by 4 can be reduced. So you're going to see that they get 15, right? 60 divided by 4 is 15. And they go through this. They did what I did, right? They did it the other way, but we went over 4 and up 60, right? They did y2 minus y1. There you go. That's the same thing I got. Up 60 and over 4, rise over run, which equals 15. So that represents $15 per hour to take piano lessons. $15 per hour. If you want to take lessons for 4 hours, you're going to owe 60 because that's 4 times 15 is 60, right? So let's go on to the new topic here. I'm glad we got a little chance to review. We are going to go on to starting linear equations, all right? We talked about I've mentioned y equals mx plus b. That is what we call a linear equation. We're going to jump into this and let's see this. Let me see if I can share this so you guys can hear it. Hopefully this works. Share the realize. There we go. Okay, it worked this time. So you guys should be able to hear this.
How does slope relate to the equation for a proportional relationship? Think about this question during the lesson. The students in Meg's class are building a fence around the class garden. How can they use the pricing for different lengths of fencing to determine the cost for 50 feet of fencing? We need to start by looking for a relationship. What is the relationship between the length?
We did this one, didn't we? I remember this one from Thursday. See, I forgot my piece of paper where I wrote down everything where we left off. I'm going to skip through this because we've already done this. We did this one too. Write an equation to describe the relationship shown in the graph. Well, they used to drive 80 miles, they used 4 gallons, right? So your rise is 80 and your run is 4. 80 over 4 is what you're going to get right here. And you can use this point 0 as a second point. Oh, it wants us to use, I see what it wanted us to do. They wanted us to put a point here and do 4 minus 3 and use the point 360, right? You end up getting 20 miles per 1 gallon. So this is your slope, 20 over 1, right? For every 1 gallon, you go up 20 miles. So your form is y equals 20x, which is the same as 20 over 1, right? That's the slope. So your slope in an equation, if you have y equals mx plus b, your slope is attached to the x. We represent that as m, right? If we are saying y equals mx, m would be the slope. We'll talk about what the b represents later. But m represents the slope. This is a linear equation. This represents a line. Let me go on to where we left off here. All right, this is where we left off. This is new. Sorry about the confusion. A drone descends into a mining cave. So if it's descending right away, that should tell us it's what? Is it positive or negative? Is the slope going to be positive or negative if it is descending? What do you think? You look at the graph right here, right? We just talked about that at the beginning of class. If it is going down from left to right, remember everything is left to right on slope. If we are going down from left to right, it would be a negative slope, which makes sense because it is descending. It is going down, right? And you can see the graph here of the drone going down into the mine. The graph relates its distance below ground to time. Write an equation that describes the relationship. So we need to find the slope, and then all we need to do to write an equation is put that into the y equals mx plus b form. So let's look at the slope here. I'm going to try to zoom in and blow it up here a little bit. All right. We start at 0. Let's use this because in 1 second, so 1 second is actually 2 boxes. So don't get confused by this. 1 second is 2 boxes in this particular graph. But in 1 second, we go down. There's a point that intersects that's on the line. We go down 250 meters, right? So our rise is actually negative 250, right? Our rise is how much up, down. So our rise is negative 250, and our run is 1. So that's going to be our unit rate, and that's going to be our slope. Whoa, going the wrong way here. Negative 250 over 1. Right? They're going to use the y2 minus y1 method. So again, y2 is negative 250, y1 is 0. So 250 minus 0 is negative 250. x2 minus x1, 1 minus 0 is 1. All right, they used different points than I did. They used this point and this point to get there, right? They used negative 750 in 3 seconds and negative 500 in 2 seconds. That's what they used. But they still got what I got, right? Our slope is negative 250 over 1. That would be the slope if you were asked in delta math, which you would have to simplify to just negative 250, right? The slope is negative 250. The drone descends 250 meters per second. So now it's going to show us how do we write this as an equation? We know that it has to be in y equals mx, right? We're not doing any plus b's yet. We'll talk about what that is later. But it's in this y equals mx. That is a linear expression or a linear equation. We know that the m is going to be where the slope goes. So we just need to plug in the slope into the m spot. All you got to do is change the m to what your slope was. That's what they did. Y equals negative 250 times x. And we know that two things next to each other that don't have a sign represent times, right? Multiplication. So that's it. Y equals 250x or negative 250x. That equation represents this line. Like if you have one of those graphing calculators, the TI-83s, and you punch it and you go into linear expression mode or linear equation mode, and you punch in y equals negative 250x, the graphing calculator will graph this line, right? It will spit out a graph that looks exactly like this line. Negative 250x, y equals negative 250x. Everybody with me? Kind of making sense now? We talked about slope. We know how to do slope. Now we know where slope goes in the linear equation. Y equals mx. M is the slope. B is the y-intercept, but we haven't got there yet. Y and x are going to be your two values on the points, right? So let me show you how this works. If I plug in or substitute a number for x, I multiply that number by negative 250, and that's going to tell me y. So let's try that out. That's a big difference between two clicks. But let's say I plug in 3 for the x value, right? Because we know that x is left and right. So I plug in 3 for x. Well, I'm going 3 times negative 250. 250 times 3 is 750. And then there's a negative sign out front. So 3, negative 750. And look, that point is on the graph. At 3, we are at negative 750. So this equation will work for any point along this entire line out into infinity, because you can see the arrow pointing down that it keeps going and going, right? This line goes into infinity. We could figure out how low the drone would be after 47 seconds, right? All we would have to do is negative 250 times 47. And we would obviously want to use a calculator for that. You guys can't see my calculator, but after 47 seconds, the drone would be negative 11,750 feet, which is probably impossible. Well, yes, it is. It's impossible. physically it's possible, but in practicality it's not, because you would be in the core of the Earth, and the helicopter would melt, because all there is down there is magma and really hot stuff, right? So it wouldn't take long for this helicopter or this drone to get as far down as it could possibly go in this mine, right? It's a fairly fast drone, and they use drones for stuff like this, especially if, let's say there's like some kind of poisonous gas down there, and they don't know what's causing it. They have to evacuate the miners for their own safety. They can send a drone down there to kind of try to investigate and see how they're going to fix the problem, and examine what's going on. And they can also use the drone to find whatever they're mining for without people having to go down there, right? If they're trying to mine diamonds or gold or whatever they're mining, they can send a drone down there instead of sending a human, especially if it goes really deep into the ground. It's much easier to just send a robot. All right, let's go on to 2.7 example 3. It's asking us to graph an equation. A recipe for trail mix calls for 1 cup of raisins for every 2 cups of granola. Okay, so there's our unit rate. 1 cup of raisins per 2 cups of granola. In this instance, it's a proportion instead of a unit rate, but it's the same idea. Write an equation that describes the relationship between raisins and granola, then graph the line. We already know what our slope's going to be. 1 cup per every 2 cups. It really should have said per, because that would have tipped us off on what to do. 1 cup of raisins per 2 cups of granola. So I'm going to go over here, and it's not going to work again, of course. Oh. 1 cup of raisins per 2 cups of granola. All right. So, or our slope of the line is going to be 1/2. Right? That's going to be our slope in raisins per granola. 1/2. 1 cup of raisin per 2 cups of granola is the recipe. So let's see what they got here for us. They got the same slope we did, 1/2, right? 1 cup raisins per 2 cups granola. Now they made a graph, right, with each box representing 1 cup of whatever ingredient. So our rise is 1, up 1, right? And our run was 2. 1 cup of raisins, 2 cups of granola. So we went up 1/2, and we got this point. Notice that if we go up 1/2 again, we have another point that is also on the line. If we were to go up 1/2 again, we'd have another point that was along the line. And up 1/2. You can see how I'm still in a straight line. Up 1/2. If you continued this line as up 1/2, it would continue to go straight, because we have a proportional relationship. So all they needed to do was take the y equals mx, that's our linear form, y equals mx, and substitute the slope, right? M is, well, I did that wrong. M is the slope. So y equals 1/2 x. That's it. Y equals 1/2 x. We just wrote an equation that models this graph. And that literally means up 1/2, right? This means up 1/2, which is a point that's on the line. Everybody with me? Anybody have questions over this? Anybody confused? All right, I'm going to go on. Write an equation of this line. All we need to do here, don't get too freaked out by this. Might be like, I don't know how to do this. All we need to do is find rise over run. I'm going to use red for rise, and I'll use green for run. First off, I need to find a point. Well, let's do that first. First off, I need to find a point on this line that intersects at a perfect spot on the grid line. One of them is this center point right here, 0, 0, right? Color that in a little bit, best I can. It's not really letting me do it that well, so I'll just circle it. Right? There's a point, 0, 0. X is 0, Y is 0. It's right in the middle. It looks like another point that is a perfect intersection is going to be right here. At, well, let's see what it is. 2 spots is 10, right? So that means each one spot is 5 units. 5, 10, 15, 20, 25. So X is 25, and this one's also going by tens. 5, 10, right? So I'll use run in red, or rise in red. Rise was 10, and our run was 25. So our slope is 10 over 25. The one problem with this is it is not reduced yet. We went up 10 and over 25, but we have to reduce this. Both of these numbers are divisible by 5. So if I divide 10 divided by 5, I'm going to get 2. And if I divide 25 divided by 5, I'm going to get 5, right? We always need to put this in simplest terms, which may or may not be the hardest thing to do on this in this whole thing, depending on how you do math and how you like to do things. So our slope is 2 over 5. So if we want to write an equation for this, all we need to do is put 2 over 5 into our slope. Our m is our slope, right? So y equals 2 over 5x. Simple as that. That is an equation that represents this line. That is the equation. I shouldn't say that's an equation. That is the equation that represents the blue line in the graph. I'm going to leave that up for a few seconds to let you guys kind of process that and take that in. Any questions over that? How we doing? Does everybody understand the slope is rise over run? Right? I wrote over the 10 a little bit, sorry. Our rise was 10 and our run was 25. We went up 10. Oh. Up 10. And then over 25. Rise over run. Rise is up, down. Run, we always want to go to the right. Like if you do it like this, if you were to say, well, we went down 10 and left 25, that's going to screw you up because technically left is negative, right? So your slope here, if you went down 10 and left 25, would be negative 10 over negative 25. You'd still get the same answer, but it's just confusing. There's no reason to confuse yourself. You still get the same answer because negative divided by negative is positive, so that's the same as 1025, which is the same as what we got, 2/5. But there's no reason to ever go left when you're finding a slope, because that's just going to mean that your x has to be negative, and that will confuse you. So make sure you always go to the right. Always go to the right if you are looking at slope and trying to find the slope of a graph. Right? Don't do this. It will just confuse you. You can get to the right answer that way, but it's unnecessary, unnecessarily confusing. I would recommend against it. Right? All right. Questions? Are we ready to move on? Okay. All right, this is cool because we can actually drag the points to make a graph here. Am I still presenting my screen? Yes. Cool. So, graph the line y equals negative 3x. So, what we need to do here is pick some points. Oh. I'm going to put that point right in the center, right? I like to do that. If there's no plus b, if there's no plus b on the end of this linear equation, it's just y equals mx. In this case, y equals negative 3x, because negative 3 is going to be our slope. If there's no plus b, that means it crosses right at the origin, the 0, 0. It also means we have a proportional relationship, right? So now I'm going to take this second point. It's going to go somewhere else. I don't know where yet, but I'm going to put it, I'll put it right here for now, for the sake of clarity. All right, so the slope of negative 3 means rise over run, okay? So if I've got negative 3, that is the same as negative 3 over 1, right? If there's nothing down here, if we don't see anything down here, it's the same as being over 1, correct? Because anything divided by 1 is itself. So if you see the slope as 22, you know that means 22 over 1. If you see the slope as 9, it means 9 over 1. Up 9 and over 1. We have negative 3 over 1. So we have to start from this first point and go down one. Well, let's just drag the second point. Second point, our rise is negative 3. 1, 2, 3. And our run is 1. 1. That's it. That's all there is to that. Y equals negative 3x. This is the same as negative 3 over 1. So we went down 3 and right 1 and put another point, right? You see how that works? Start at the first point, go down 3, go over 1, plot the second point. So our rise, or our slope, I should say, is negative 3 over 1. Rise was negative, down, and run was positive, to the right. Questions, comments, concerns, thoughts? Anything. All right, no questions. Let's do one more example. Grain is being released from a silo at a constant rate of 14 pounds per minute. Silo is one of those giant buildings that you see on farms, right? It looks like a giant, I don't know, it looks like a giant tank almost, like, I don't know. There you go, right? You ever drive out in the country and you see these big tank looking things? That is where they store grain that they have grown. Like they store corn, wheat, whatever. Could be whatever, right? That's called a silo. They store it, and then when the truck comes to take it to the wherever it's going to be sold to the market, the truck will come and just hook up right to the side of this. They have a pump that pumps the stuff up to the top so they can fill it all the way to the top with whatever grain they grow at the farm. And then the truck comes and backs up and just empties it out the bottom right into the truck, right? That is for storage of crops. Grain is being released at a rate of 14 pounds per minute. Write an equation that represents the change in the amount of grain Y after X minutes. So again, we are going to write an equation in the form Y equals mx. Y equals mx. So grain is being released. First off, let's figure out, is that going to be positive or negative? Grain is being released from the silo. And we need to write the equation that represents the change in the amount of grain that's still in the silo. So is the silo losing grain or getting more grain? Is the grain in the silo going down or is it going up? If it's being released, it is going down, right? Say they had 5,000 pounds of grain and they are releasing some into a truck that's going to go to the bakery and drop off a load of wheat at the bakery to bake bread. They are releasing it at 14 pounds per minute. So we know that our Y value is going to be negative. I can't write on this, so I'm going to do it on the whiteboard. This is actually already telling us the slope. 14 pounds per minute, and it's being released. So we know it's negative. So our equation for that scenario is, again, we're going to use Y equals mx, and our slope is negative 14, right? The silo is losing 14 pounds per minute. Y equals negative 14x. That's it. That's the equation. Simple as that. So we always know after X amount of time, there will be Y grain remaining. Or, I take that back. After X amount of time, there will be Y grain that is now gone, that is now loaded into the truck. That's what that would represent. After this much time, if we put in 10 seconds, after 10 seconds, 10 times 14 is 140. So 140 would be this Y, which represents how much grain they just pumped into the truck, right? So now we need to find which ordered pairs are here. So let's try this out. This is x comma y, remember, x comma y. So at x, if x is 0, 14 times 0 is 0. So if x is 0, y is 0. Right? Let's do 1 here. If x is 1, 1 times negative 14 is negative 14. You can even make a chart on this. Let's do this. Oh. You can make what's called a T-chart. When x is 0, y is 0, right? Because 0 times negative 14 is 0. When x is 1, 1 times negative 14 is negative 14. When x is 2, 2 times negative 14 is negative 28. When x is 3, 3 times negative 14 is negative 42. When x is 4, again, we're counting by 14s here, right? Because we're just multiplying by negative 14. When x is 4, y is negative 56. When x is 5, that would be negative 70. 5 times, I put a 5 in there, 5, oh, my bad. 5 times negative 14 is negative 70. That's how I'm getting that. Okay, so let's go back and look at the problem and put these things in the correct order. We're looking for 1 comma negative 14, 2 28, 2 negative 28, I should say. That's not one of them on here, so we'll skip it. 3 negative 42, that one is on here. 4 negative 56, I don't think I saw that one. 5 negative 70. Nope, there's a 5 negative 90, so we know that's wrong. This one we know is wrong because at 0 it should be 0, 0. This one we know is wrong because at 1 it should be negative 14. This one's positive 14. Anything with a positive y value has to be wrong because our slope is negative. So our y value is going to be negative. We know that's going to be wrong because it's 0, 0, again, right here. So anything with 0 has to be 0. So let's think about 10. We're looking at 10. 10 times negative 14 equals negative 140. So at 10 seconds, we're going to be negative 140. That's correct. And it's not going to be negative 100. That's wrong. So that was kind of what it's asking us to do. But the biggest thing is, here's your equation for the line in y equals mx. That is your equation. If you wanted to graph this scenario, if you wanted to graph this, the equation would be y equals negative 14 times x. And that's what they got. That's what we got. We substituted negative 14, which is our slope, for m, because m represents slope in this equation. In every equation that's dealing with linear, graphing linear equations. Y equals negative 14x. I'm not sure they're going to graph it, but if we were going to graph that, we have a graph. This is y and this is x. After 1x, y would be, let's say these go by 5s. Would be here, right? This is 5, 10, 15, 20. After 2 seconds, 25, 30. It would be here, right, at 28. So do you see how at 0, 0, see how this would start to make a line? Right, my artwork is not perfect, but at 3 seconds, what was our value for 3? 42. So this is 35, 40. So it's going to be again right about there. right? Just a little bit below 40 is 42. So you can see how this thing is going to start making a straight line. All right, we're almost out of time here, guys. Does anybody have any questions over this stuff with linear equations? Once you guys master slope, the linear equations is really not that bad. Okay, we already did one like this. 1 cup of raisins per every 4 cups of granola. We already did one just like this. It's asking us to write a linear equation. You need to remember that number one, slope is rise over run, and linear equations equal are y equals mx plus b. And in this case, the slope is m. In every case, the slope is m. Okay? You need to know how to find the slope. It's rise over run. And then you need to know where the slope goes in the linear equation. Y equals mx. M is always the slope. I'm going to leave that up here for a moment or two to just let you guys process that for the end of our lesson today. We'll talk about what this plus b means later. We'll get into that next lesson. That's something different. But this m is the slope. And this is what every single linear equation ever is going to look like. Y equals mx plus b. That is called a linear equation. Questions? Thoughts, comments, issues, major concerns? All right, guys, it is time for you guys to be dismissed. Have a great rest of the day. Head to your second bell, and I will see some of you later during study skills. Thanks for being here this morning.